Exponential growth and decay, part 2. The equation that we've been using for exponential growth and decay is y is equal to a times b to the power x. Now, each of these letters represents something different. When we have the y represents the final amount. Now, final amount could mean the value, the final amount of the population, etc. A is the initial amount. Once again, these two are related. So if we're talking about value, this is the initial value or initial population. B is our growth or decay factor, depending on whether this is growth or decay. And X is the number of cycles. Now, just a side note about growth and decay. We need to always consider it as a percentage, and we're going to be taking 100% plus our growth rate, and decay would be 100% minus our decay rate. But we also need to make sure we convert this into a decimal. Now, today, the lesson is instead of solving for y, we're going to be solving for some of the other variables. First, we're going to start with solving for the letter A. A collector sold a rare stamp for about $138.84. He originally bought it 20 years ago, and the stamp increased in price by 8% each year. How much was the stamp when the collector originally purchased it 20 years ago? Now, let's sort out the information we have. As an exponential growth question, we know that this question will involve y, a, b, and x. So, a collector sold a rare stamp for about $138.84. He bought this 20 years ago. But at 20 years ago, that was not the price. This is the price right now. He bought it 20 years ago. We don't know what it is, and we're looking for the original amount. So 138.84 is our final amount. The A is what we're looking for. How much was the stamp originally purchased for? We don't know. Next, our growth factor. We know that the price is increasing, so it's 108% each year. 108% as a decimal is 1.08. And finally, our x is the number of years. And in this case, it was told that the years we have is 20. Now, let me rewrite the equation with all of the information that I have. Y is equal to ab to the power x. 138.84 is equal to a times 1.08 all to the power of 20. Now, we are looking for a, and we can use algebra for us to solve this. I'm going to divide 1.08 to the power of 20 to both sides so that a is isolated. 138.84 divided by 1.08 to the power of 20. This is equal to a. So we pull out our calculator. We have 138.84 divided by 1.08 to the power of 20. The answer 29.787. Let's round that. So we have A is equal to 29.8. Sorry, what was it again? 29.78. 787. We're going to round that to $29.79. We could say that this stamp was originally purchased at about $29.79. Right, another question similar to that. We have a colony of bees increase by 25% every 3 months. So the whole 25% increase doesn't happen every month, but it has to happen every 3 months. How many bees did Omar start with 18 months ago if he has 10,000 bees now? Let's sort out the information: Y, A, B, and X. Now, the fact that we have 10,000 bees now means that this is the final amount, and the original amount is unknown. We know that it increases 25%. So every time the bees increase, we're increasing by 25%. So we're going to say 125 or 1.25 as a decimal. Now, X is not going to be just every month, because this rate that we're given is 25% every 3 months. So we're going to take the number of months and divide it by 3. Because if we don't hit 3 months, it's going to be increasing by a fraction of what it is. Now let's substitute this into our equation. Y is equal to AB to the power X. 10,000 is equal to A times 1.25 to the power of M over 3, where A is the original amount and M is the number of months. Now we know that Omar had started 18 months ago. We're inserting 18 into our months. So we have our equation: 10,000 is equal to A times 1.2 to the power of 12 over 3, or we simplify that to a 6. So 10,000 divided by 1.25 to the power of 18 over 3. That's all equal to A. Let's insert that into our calculator, and we get an answer of 2,621 and 44 cents. We have A is equal to 2,621. Now, it's not possible for us to have 0.44 of a B. So let's just keep it at 2,621, and that's the number of bees that he probably started out with. Right, pause the video, and I'm going to give you some time to work on these questions. Hey, sometimes we need to use technology to solve for variables, especially if we're looking for the B or the X. Let's try this question. Suppose you purchased a rare coin for $350, and each year the value appreciates by 8%. How many years would it take for the stamp to be worth $500? Y, A, B, and X. Now, according to the question, the goal is we're trying to find out the final amount when the final amount is worth $500. The initial value of the coin, 350, and each year the value appreciates by 8%. So that means we're increasing by 108%. So this becomes 1.08 as a decimal. And finally, x is the number of years. We don't know what the number of years is, and that's actually the question. How many years would it take for the stamp to be worth $500? Y is the number of years that we don't know, and we can insert this into our equation. Y is equal to AB to the power of x. So 500 equals 350 times 1.08 raised to the power of x. Now, for this question, we are going to separate this into two parts. You need to go to desmos.com and use the graphing calculator. You'll see a box that looks something like this. In your first box, we're going to write the left side of the equation. So enter equation 1. Equation 1, y is equal to 500. So the first and the left side of the graph. The second equation, I'm going to enter number 2. We have y is equal to 350 times 1.8 to the power of x. So desmos.com, or there's a graphing calculator here that I pulled up on the screen. The first equation, I'm using y is equal to 500. The second one, I'm entering my second equation. Y is equal to 350 times 1.08 to the power of x. Now, you'll notice that you can't see it on the graph yet, and it's because these two graphs are so far up on this graph that we can't see it. I need to go up to the wrench where I can see the settings, and I'm going to change the values of my y-axis and the values of my x-axis. Now, I know that here it says y is equal to 500. So I'm going to make it go up to a number that's higher than 500. So for example, I pick 600. All of a sudden, inside my field of view, I see the graph. Now, when I click on the point of intersection, I get a coordinate, and the coordinate tells us what the answer is. The coordinate gives us our x value and the y value. Now, back to our question originally, we're looking for the x. So the x value is 4.6. Point of intersection, 4.63 and 500. Now remember that our coordinates are always written in the format x and y. So they've told us that the x value is 4.63, and that answers our question. X represents years, and we know that the stamp or the coin uh, is worth $500 in 4.63 years. Now, sorry about that. I just realized that this question, the initial part it says coins, the other part it says stamps. I did mean the same item. Now we can do this again for solving for the value of B. You purchased an antique car for $90,000. In 10 years' time, you found that it was now worth $181,710. What is the appreciation rate each year? We are looking for the growth rate for this car. Let's sort out the information we have: Y, A, B, and X. Y is the final amount or the final value of the car, $181,710. A is the original amount. The car initially was worth $90,000. B is our growth factor. Now, growth factor is always created by 100% plus the growth rate. The growth rate in this case is the same as the appreciation rate. So let me say this is the letter G for growth. Now, as a decimal, I would have 100 divided by 100, that's 1, and whatever our growth rate is as a percent is going to be divided by 100 as well for the letter G. Finally, we have X, and we know that this is years. They've told us that the two prices, they've differed based on 10 years time. Now let's take the information. We're going to put this all into our equation. 181,710 is equal to 90,000 times 1 plus g raised to the power of 10. So once again, let's go to Desmos, and we need to enter our equation, but in each row we put the left side separately, then we put in for the right side. So on the left side, we have y is equal to 181,710. Other side, we have y is equal to 90,000 times 1 plus g raised to the power of 10. Now, the calculator doesn't necessarily understand what g is. I'm going to change it to the letter x just for simplicity's sake. Now, because our x-axis and y-axis is too small, we need to change the values as well. The y, we know that it goes up to 181,710, so I will insert 200,000 as my maximum. Once I have that, I see the two lines intersecting, but it's still not a very good close-up. The G we know is a percent, and percentage, if it's less than 100, is going to be a decimal value between 0 and 1. So I will change my x-axis to a number between 0 and 1. Now, here's our graph. We find the point of intersection. The point of intersection is 0.0728 and 181,710. So the x value, or in this case, the g value, the growth rate as a decimal is 0.0728. Now, for us to convert this back into a decimal, we're going to multiply it by 100, and we get 7.28%.